Knowledge distillation is a powerful technique in machine learning that involves transferring knowledge from a larger, more complex model to a smaller, more efficient model. This process can enhance the performance of the student model while reducing its computational requirements. Here, we will explore three specific methods of knowledge distillation: adversarial distillation, multi-teacher distillation, and cross-modal distillation. Adversarial distillation leverages adversarial training techniques to improve the robustness and performance of student models. In this approach, the teacher model is trained not only to provide probability distributions over classes but also to generate adversarial examples that challenge the student model. The teacher model generates adversarial examples during training, which are then used to train the student model. This process helps the student learn to generalize better by exposing it to difficult cases that it might not encounter in the standard training set. This method enhances the student model's ability to handle adversarial attacks, making it more robust. It also allows the student to learn from the teacher's feature representations, which can lead to improved performance on unseen data. Adversarial distillation is particularly useful in scenarios where model robustness is critical, such as in security-sensitive applications or environments with noisy data. Multi-teacher distillation involves using multiple teacher models to provide diverse knowledge to a single student model. This method capitalizes on the strengths of different teacher models, allowing the student to learn from a broader range of perspectives. In this approach, each teacher model may be trained on the same or different data or may utilize different architectures. The student model learns from the combined outputs of these teachers, often through a weighted average of their predictions. This method can lead to improved performance as the student benefits from the complementary knowledge of various teachers. It also helps mitigate the risk of overfitting to a single teacher's biases. Multi-teacher distillation is particularly effective in complex tasks where no single model can capture all the nuances of the data, such as in multi-class classification problems or when dealing with heterogeneous data sources. Cross-modal distillation is a technique where knowledge is transferred from a teacher model trained in one modality such as image to a student model that operates in a different modality such as text. This method is particularly useful when labeled data is scarce in one modality but abundant in another. The teacher model, trained on a specific modality, generates features or soft labels that are then used to guide the training of the student model in a different modality. For example, a model trained on image data can help train a model that processes text descriptions of those images. This approach allows for leveraging existing knowledge across different domains, improving the performance of the student model even when it has limited training data in its own modality. It can also facilitate multimodal learning, where models learn to integrate information from various sources. Cross-modal distillation is particularly useful in applications like visual question answering, where the model needs to understand both visual and textual information. This table shows key features, benefits, and typical application under different training techniques. According to different needs, different techniques may help on specific needs. For example, adversarial distillation may help in preventing adversarial attacks. Multi-teacher distillations can reduce overfitting. Cross-modal distillation leverages a large amount of data in modality to another modality such as image, audio. In summary, each of these distillation methods offers unique advantages and is suited for different scenarios. Adversarial distillation focuses on robustness, multi-teacher distillation enhances generalization through diverse knowledge, and cross-modal distillation enables knowledge transfer across different data types. Understanding these methods allows practitioners to choose the most appropriate approach based on their specific needs and data availability.